Welcome everyone. In this video, we are going to learn about the conjugate of surds. This is the learning outcome for this subtopic. When a surd appears in the denominator of a fraction, we usually rationalize the denominator by multiplying the numerator and denominator by itself or its conjugate. The example is shown in the table. When the surd is a single term like square root of 3, the conjugate is equals to itself. When there are two terms like 3 plus square root of 2, where only one of the terms is surd, then the conjugate is 3 minus square root of 2. This means that we change the sign of the surd from positive to negative. When both terms are surds, like the example square root of 2 minus square root of 3, then the conjugate can be either square root of 2 plus square root of 3 or negative square root of 2 minus square root of 3. This means that we only change one of the sign. It's either we change the sign of square root of 3 from negative to positive, or the sign of square root of 2 from positive to negative. The conjugate of square root of a plus square root of b is square root of a minus square root of b, and the multiplication of the surd and its conjugate equals to a real number a minus b. In order to get the real number a minus b, we have to expand the expression. So here's how we expand it. First, we multiply square root of a with square root of a, and we get square root of a squared. When we multiply square root of a with negative square root of b, we can write it in a single surd negative square root of ab. And same goes when we multiply square root of b with square root of a. We can write it in a single surd square root of ab. Then the last one is to multiply square root of b with negative square root of b. We get negative square root of b squared. From this expression, we can cancel out the square root of ab, which leave a minus b, where a comes from square root of a squared and negative b comes from negative square root of b squared. So let's do the exercise. For this question, we want to rationalize 5 over square root of 3. In order to rationalize this, we must multiply it by the conjugate of the denominator. Since the denominator is a single surd square root of 3, so the conjugate is itself. Both the numerator and the denominator must be multiplied by square root of 3. After multiplying, we get the answer 5 square root of 3 divided by 3. For this question, the conjugate of the denominator is 7 plus square root of 2. So, multiply to both numerator and denominator with the conjugate. For the denominator, it is better if we expand it one by one. So, please look carefully on how to expand this. 7 multiplied by 7 equals to 49. 7 multiplied by square root of 2 is equals to positive 7 square root of 2. Negative square root of 2 multiplied by 7 is equals to negative 7 square root of 2. And negative square root of 2 multiplied by square root of 2 equals to negative 2. After that, simplify the denominator and it becomes 47. However, we usually state the final answer in the form of a plus b square root of c. That means you have to split this single fraction into two fractions, where a is equals to 7 over 47, b is equals to 1 over 47, and c is equals to 2. For this question, both the numerator and denominator are surds. Please bear in mind that when we multiply by conjugate, it must be always the conjugate of the denominator. So for this one, the conjugate is 5 plus square root of 3, multiplied to both numerator and denominator. We have to expand both numerator and denominator. For the numerator, we must multiply 2 square root of 3 to both 5 and square root of 3. And we get 10 square root of 3 plus 2 multiplied by 3. For the denominator, we have to expand 1 by 1 and we get this. Simplify the numerator and denominator, then split it into 2 fractions and simplify to get the simplest answer in the form of a plus b square root of c. This question involved the subtraction of 2 fractions in surd. So, we multiply both fractions by the conjugate of its own denominator. After that, expand the numerator and denominator. Then simplify it. Most students had problem to solve this part. So, it is better if we multiply the negative operation and the denominator -1, which will become positive. And this expression will become like this. Then cancel out the -3 and 3 and we get the answer. Please submit this exercise to your lecturer before class ended. Thank you.